Hi everyone, this is the Model and Solve Equations assignment for 7th grade. Okay, there's a 6th grade one that's very similar, but this one's the 7th grade one. So if you're not in 7th grade, then go watch the 6th grade one. Okay, so for this one, we are modeling and solving two-step equations. Okay, so for each question, there's a model mat, and then there's a algebraic solution slide. Okay, same problem. So we're going to model first. We're not solving here, just modeling it. Then you're going to solve. When you are solving, you have a couple options. You can take a screenshot of your slide with the question and solve on your screen, showing your work just like I do, the way that I do. Or you can write it down on a piece of paper and then insert an image into your slide. Okay, if it's easier to write, which I personally think it is easier to write, I'm going to do it on my screen, but I think it's probably easier to write this down. So if you have a piece of paper, pencil, or a whiteboard, you can write each problem down and then insert your images if you like. If you don't know how to insert your images, you can ask me in class and I'll help you out. Just save your work. Okay, so number 1, 2x plus 4 equals 12. This is a two-step equation. You're only used to solving one-step equations. So first let's model this and then I'll talk about how to solve a two-step equation. 2x, all right, so my left side is going to be 2x plus 4 because that is the left side of my equation. So I'm going to go ahead and model that using these pieces. I've got two x's, two positive x's, and then a positive 4. So this positive 4, we're going to use the 1 counter because that's 2x plus 1, 2x plus 2, plus 3, and plus 4. Okay, so that's 2x plus 4, and it equals 12. No x's over here, just regular old 12. So I'm still going to use these 1 counters, and if you want, you can drag all 12, or you can copy and paste to get your 12. I'm going to copy and paste by 2s. 2, 4, 6. Actually, now I'm going to copy all 6 of these and double it to get my 12. Whatever is easier for you. Boom, there's my 12. 3, 6, 9, 12. Okay, so I see 2x plus 4, and it equals 12. That's all we have to do for the modeling side. And again, if I'm going too fast, you can always pause this video or watch it again. Okay, so how do we solve a two-step equation? Okay, so in my lesson video or in class when we talked about this, you can reason a lot in your head on what your variable could be. Okay, so if I thought x were 2, for example, let's see if that makes sense. X 2 times 2 is 4, plus 4 is 8. Oh, that's not enough. Maybe it's 5. 2 times 5 is 10, plus 4 is 14. That's too much. But what you're doing when you're reasoning, I'm sure you could solve this in your head eventually, but it takes a lot of time because you're guessing and checking. So we want to solve equations using inverse or opposite operations. And when we solve this way, you're always going to get to the solution. This is the path to the answer. There is no guessing and checking and seeing if it's right and adjusting. Okay, so that's why we want to work on actually solving these problems. When you're solving two-step equations, you are always going to check first to see if you have to add or subtract. And remember, if you see addition, you're going to subtract. If you see subtraction, you're going to add because these are opposite operations. That's your first step. And then you're going to work on multiplication and division. If you see multiplication, you'll divide. If you see division, you'll multiply. Okay, so always check for addition and subtraction first, and then multiplication and division. All right, I'm going to start to solve this. I'm going to highlight this x because we are trying to solve for your variable. We want to know what that x is going to be. I'm going to draw my line down my equal sign. Okay, when you're showing your work, show your work just like I do. First, we need to see, is there addition or subtraction happening? And remember, we're trying to see what's happening to your variable, okay, on the same side as your variable. So we're looking at this left side. This 12 is really just minding its own business. Don't worry about that 12. What's happening to your letter? Okay, 2x plus 4. So we do have addition. We do have plus 4. So what is the opposite of plus 4? Minus 4. So we're going to subtract 4. And like a balance beam, what we do on one side, we have to do to our other side. So we have to subtract 4 over here as well. 4 minus 4, okay, that's 0. So we're left with 2x. 2x equals 12 minus 4 is 8. Okay, 2x equals 8. We're not done yet because we want x to be by itself. Is there any more addition, subtraction? Nope. Now we're going to move on to multiplication, division. What is happening to your variable? Your variable is being multiplied times 2. This is you have 2 x's. This is times 2. So what is the opposite of multiplication? Division. So we're going to divide by 2. Again, this 8 is just minding its business. We're focused on doing the opposite of what's happening to your variable. 2 divided by 2, that's 1. So we're left with just a single x. What does x equal? 8 divided by 2 is 4. So x is 4. Okay, so a little bit longer of problem solving than what we did last year. There's 2 steps. This time we had to subtract and then we had to divide. And you can go ahead and write this answer number 4 right here in this box. Final answer, x equals 4. Equations are very easy to check your work with. 2 times 4 plus 4. Okay, so 2 times 4 is 8 plus 4 is 12, which is what it should be. So this is correct. All right, I'm going to keep going, but again, good thing about these videos is you can rewind it, watch it again, do whatever you need. All right, number 2, let's model 11, just regular plain 11. So I'm going to go ahead and drag in 11 of these ones. You can copy and paste 11 times if you like. I'm going to drag 5 and then double it to get 10. So 5, 10, and then one more. That's 11. Equals 3. Okay, still positive 3 counters. 1, 2, 3 equals 3 plus 4x. And 4 positive x's. You can copy and paste if you like. Whatever is easier for you, as long as I can see that equation in your model. Okay, so I've got a positive 11 equals 3, positive 3 plus 4 x's. All right, now time to solve. Okay, I went ahead and I highlighted my variable x so I don't lose track of it. I drew my line down my equal sign to represent the 2 sides of my scale. And I went ahead and I wrote down over here, first we're going to check for multiplication and, addition and subtraction. They're opposites. And then we're going to check for multiplication and division. Those are opposites. This time my variable is on the right side. No worries. What's happening to my variable? Okay, that 11 is on the other side. I want to know what's happening to my variable. So I've got 4x's plus 3. Okay, so 3 plus 4x. I want to go ahead and get rid of this plus 3, this positive 3. How do I get rid of a positive 3? Let's take it away. Let's subtract it. Subtract 3 from both sides. Okay, so 3 minus 3 is 0. So I'm left with 4x over here. 11 minus 3 is 8. Okay, I'm still not done yet because I want x to be by itself. I'm done with addition and subtraction, so now I'm going to check for multiplication and division. This is multiplication right here. So the opposite of times 4, x times 4, is divide by 4. We represent division using a fraction. Okay, fraction's division. 4 divided by 4 is just 1, so we're left with 1x. And what does it equal? 8 divided by 4 is 2. So x is 2. Make sure you're showing all your work. Just putting this x equals 2 in this box isn't going to be sufficient. You got to model and solve. And let's check our work. Does that make sense? Does x equal 2? I'm going to go ahead and get rid of this so we can see. 3 plus 4 times 2. 4 times 2 is 8. 3 plus 8 is 11. Correct. Next. Okay, we're going to model our next problem. -7 this time. So we're going to use the negative counters. 1, 2, 3, 4, 5, 6, 7. Let's make sure that's right. Is that right? 1, 2, 3, 4, 5, 6, 7. Yep. Okay, so -7 plus 4 x's. 4 positive x's. 1, 2, 3, 4. Oops, too many. Okay, equals a positive 5. 1, 2, 3, 4, 5. -7 and 4 x's plus 4 x's equals positive 5. All right, let's solve this. I'm going to go ahead and set everything up. Okay, here we are. What is happening to your variable? So our variable is x. On this side of the variable, we have that -7 we have to get rid of. We have this 4 we have to get rid of. So we're going to check for multiplication. addition and subtraction first. All right, so this is being multiplied, so we want to go ahead and get rid of this -7. Even though this is -7 plus, okay, this is actually, this -7 is what we have to get rid of. So if we subtract 7, if you're looking at that plus and you think, oh, I need to subtract 7. If we subtract 7 from both sides, that's not going to get rid of this -7, right? We want to get rid of it. You would end up with -14. So that's a red flag that that's not right. We need to add 7 to get rid of that 7 because it's a -7. So add 7 to both sides. Now -7 plus 7 is 0. So we got rid of it. That's exactly what we want because we want x to be by itself. All right. I still want that x to be by itself. Right now that 4 is in the way. This is multiplication. Opposite of multiplication is division. So we're going to divide by 4. Divide by 4. So if what you do, your opposite operation, if it does not get rid of what is next to your variable, then it is not right. It's not the right opposite operation. Maybe you didn't do the opposite. 12 divided by 4 is 3. So x equals 3. Type that in here. We're going to check our work. -7 plus 4 times 3 is 12. -7 plus 12. Is that 5? It is. Okay, we've got a couple more. -4 minus 3x. Sorry. I'm going to go ahead and drag -4 over here. 1, 2, 3, 4. Okay, -4 minus 3x. This time we have our negative x counters, which I don't think we've used yet. 1, 2, 3. Okay, so -4 minus 3x equals +5. 1, 2, 3, 4, 5. If you copy and paste, just make sure you got the right number. All right, I'm going to go ahead and set everything up. You can too as well on your piece of paper or your screenshot. Okay, remember we are doing opposite operations to solve these equations. We're checking for addition and subtraction first. -4 minus 3x equals 5. We're going to go ahead and get rid of this -4 by adding 4. Add 4 to both sides. -4 plus 4, that's 0. Now be careful, that's that minus 3x, that negative is going to come down with us. So keep that negative. Can't just get rid of that. 5 plus 4 is 9. Okay. Now we need to get rid of this -3. This is multiplication, so we're going to divide by -3. -3 divided by -3 is 1x. And 9 divided by -3 is -3. Okay, there we go. Plug that in right here. And then we can check our work. -4 minus 3 times -3. We're trying to see, does that equal 5? -4 minus 3 times -3 is -3. I'm sorry, -9. So we're adding 9. -4 plus 9 is 5. So that is correct. Okay, so I got that plus 9 because a negative times a negative is a positive. Always check your work with these. Okay, one more, I think. Oh, 2 more. Oh, these are a little different. Okay, number 5. If I have 2 bags of candy, okay, that's X, and 3 lollipops, and it totals 23 pieces of candy, how much candy was in each bag? So we're modeling this. Let's try to figure out an equation. If I have 2 bags of candy, which is X, so I've got 2 X's. Okay, if I have 2 X's and 3 lollipops. Okay, so my 2 bags of candy, and I've got 1, 2, 3 more. Okay, does that make sense? 2 bags of candy, which they told us is X, and then 3 more. And it totals 23. So it equals 23. All right, we've got a lot to copy. You can do this strategically. I'm going to go by 5s, but we need 23 lollipops over here. My equation is going to be 2x plus 3 equals 25. So there's 5. You can select all of these and copy 5. So 5, 10, 15, 20, and then I'm going to drag 3 more. try to keep them organized. Otherwise, you're going to be counting a lot of ones to make sure you have 23. Okay, that's your model. 2x plus 3 equals 23. Okay, now we actually have to solve it. So go ahead and write the problem down, your equation, and get it ready. Okay. We're going to add and subtract first, then multiply and divide. What's on the same side as your variable? I've got that 2 I need to get rid of. I got this plus 3 I need to get rid of. That 23 is on the other side. Add and subtract first. Plus 3. How to get rid of plus 3? The opposite is minus 3. 3 minus 3, 0. So we just have 2x left over here. We drop that down. 23 minus 3 is 20. Okay, so 2x is equal 20. At this point, you can probably reason that x must equal 10. We want to solve it. This is times 2, so we're going to have to divide by 2. Divide by 2. Okay, but 2x equals 20. That's pretty simple to think about. One number, when you double it, is 20. It's 10. So x equals 10. Okay, and then you can check your work. Does that make sense? 2 times 10 is 20. Plus 3 is 23. It does. Okay, now one more to go. Another word problem. I bought 3 bags X of fun-sized Milky Ways. Okay, so that's already telling us that I have 3 X's. My brother ate 5 of these candies. Okay, think about this in the situation. You bought some Milky Ways, but then they got eaten. They're gone, right? Your brother ate 5 of them. You no longer have them. So this is why we're going to use this negative counter. He ate 5. They're not there anymore. Okay, so our 3 bags of candy minus those 5 that your brother ate. If I only have 16 candies left, how many Milky Ways were in each bag? So we have got 16 left over here. Maybe we opened up bags and we have 16 pieces left. I'm going to go by 5s again. 5, 10, 15, and one more, 16. So our equation is 3x minus 5 equals 16. Okay, go ahead and write that down. Get it ready. Okay, we're going to add and subtract first if we see it, and then multiply and divide. We have to get rid of all the stuff on the same side as the variable, this minus 5, this 3. So we're going to do the opposite of minus 5 first, plus 5. Make sure you do it on both sides. Negative 5 plus 5 is 0. That gets rid of it. Our 3x comes down. Remember, if it doesn't get rid of it, then you either did your math wrong or you did the wrong operation. We're trying to get x by itself. 16 plus 5 is 21. Okay, we still want x by itself. How do I get rid of this times 3? We're going to do the opposite, which is divide by 3. Which means x is, I'm running out of space here, x equals 21 divided by 3, 7. X is 7. Does that make sense? 3 times 7 is 21. And when you subtract 5, you get 16. Does make sense. Okay, that was a lot. I hoped that was good practice, though, modeling those 2 steps, which is really just matching your equation to your little blocks, matching a picture to your equation. And then solving 2 steps is really no different than solving 1 step. Just there's 2 steps. You're going to add and subtract first, and then you're going to multiply and divide. We're doing opposite operations, and you're trying to get x by itself. You want to isolate the x. So after all your work, you have the answer. X equals blank. All right, thanks guys. Finish this up, submit. Have a nice day.